Hi everybody, so today we're going to look at calculating the number of moles of a gas, okay, and this is 2009 question 10a that we're going to specifically focus on. So if we read the question, it says calculating how many moles of gas are present in a sample containing X amount of atoms of chlorine as STP. Now, generally if I see STP and I see gas, I go to my normal formula, and that is the volume equals the number of moles multiplied by STP. And STP would be 22.4 litres, which you have to learn off. Now, the problem with that is we're not given the volume at all. If we look at it there, there's no other information there to give us the volume. But we are given the number of atoms. Now, whenever I see the number of atoms, there is another form that comes to mind, okay, and that's got to do with your Avogadro's number. And Avogadro's formula essentially, okay, if you want to find out the number of atoms, okay, the number of atoms is the number of moles times Avogadro's number. Okay, then number of atoms equals number of moles times Avogadro's number. Now, the problem with that is that's if we were dealing with essentially a solid, really, because we're not dealing with the number of molecules. Okay, in this case here, we're looking for how many moles are present in a sample containing some X amount of atoms of chlorine. Now, chlorine as a gas, okay, is Cl2, which is a molecule, okay, not an atom. Okay, so that's really, really important, okay, to remember there. So gas, how many moles of gas, chlorine, okay, so we're looking for the number of molecules, not the number of atoms, okay. So if we're so overall, we're looking for the number of moles of this chlorine molecule here. Okay, so there is a formula we can use, and that is our number. It's very similar to the one we did before with number of atoms. So number of molecules equals number of moles times Avogadro's number. Okay, and we know Avogadro's number is 6 times 10 to the power 23. That's just a constant. Now, we have to figure out the number of molecules. We are already given the number of atoms, okay, which is over here, your 1.8 times 10 to the power 24. Okay, so that's the total number of atoms, okay, and therefore, if we do, I'll just do a little side down here, 1.8 times 10 to the power 24, and we divide that by 2, okay, that will give us the number of molecules. Okay, that'll give us the number of molecules. So if we do that out in the calculator there, I have my calculator here with me, I'm going to put everything into brackets, I'm going to divide them by 2, and I'm going to get 9 times 10 to the power 23 molecules of Cl2. Okay, so we have that many molecules, 9 times 10 to the power 23. We have our formula over here. We can manipulate this to get Avogadro's number. Okay, so if we do that out again, it becomes number of molecules. We're actually not manipulating, we're manipulating it to get the number of moles, I should say. So number of molecules divided by Avogadro's number equals our number of moles. Okay, I'm just going to keep these separate. I don't want them being mixed up. Okay, so number of molecules is 9 times 10 to the power 23. Divide that by 6 times 10 to the power 23. And if we did that, we're going to get 1.5 moles of Cl2. And that's our answer. Now that was tricky, okay, for a couple of reasons. One, STP, we're thinking of the original formula, okay, but you would have figured out fairly quickly that we don't have the volume. Now the second part of it is in terms of the number of atoms. Okay, yeah, we had the number of atoms, and many of you would have been tempted to put the number of atoms here equals number of moles times Avogadro's number and did that out. Okay, and obviously you would have been wrong. And the reason you would have been wrong is we're dealing with chlorine gas. Now, it didn't specifically tell you that it was a molecule, but any gas will be a molecule. Okay, oxygen gas is O2, nitrogen gas is NO2, carbon dioxide gas is CO2. Okay, so you had to, from the number of atoms, figure out the number of molecules. And I knew that for each molecule there was 2 atoms. So I divided my 1.8 times 10 to the power 24 atoms by 2, and that'll give us the number of molecules. Okay, and I put that into a formula over here to figure out what the answer was. So look, that's it, guys. It's worth practicing those type of questions. And just like that was tricky. Okay, and again, practice will definitely help.